All right, so now we're going to learn something called Euler's formula. We're going to see the relationship of how many faces, vertices, and edges a prism contains, and if there's a relationship or pattern between that. So first, let's focus on the triangular prism. Faces, it has 1, 2, 3, 4, 5. I know it's kind of hard to see that. Vertices, change the color here. It has 1, 2, 3, 4, 5, 6 vertices. And then edges, it has 1, 2, 3, 4, 5, 6, 7, 8, 9 edges. Right? Now let's do it with the rectangular prism. So the rectangular prism has 1, 2, 3, 4, 5, 6 faces. It has 1, 2, 3, 4, 5, 6, 7, 8 vertices. And it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 edges. Okay, we have the pentagonal one that has 1, 2, 3, 4, 5, 6, 7 faces. It has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 vertices. And it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 edges. Oops. Just trying to show the colors there, right? Last, we have the hexagonal one. Hexagonal, we have the 1, 2 bases, and then 3, 4, 5, 6, 7, 8 faces. It has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 vertices, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 18 edges. Take a second and look, what's the relationship between any of these numbers? Well, you notice here, it's going up by 1 each time. So plus 1, plus 1, plus 1. Here, we're going up by 2 each time. And then here, we're going up by 3 each time. Right? If you look horizontally in this table, we'll see that faces and vertices is 5 plus 6 is 2 less than 9, right? Same thing here, 6 plus 8 is 2 more, than 12. So we add 2 to the 12. 7 plus 10 is 17. Add 2 to 15. 8 and 12, that's 20. Add 2 to the 18. So what Euler's formula is, Euler's formula says for any polyhedron, the faces plus the vertices equal the edges plus 2. Right, so looking at this triangular pyramid over here, we can identify our faces, our edges, and our vertices, right? We have 1, 2, 3, 4 faces. We have 1, 2, 3, 4, 5, 6 edges. And we have 1, 2, 3, 4 vertices. I did them in a slightly different order than up here. But notice up here we did faces and vertices. So faces plus vertices equal edges plus 2. So 4 plus 4 equals 6 plus 2, right? And that's true. We get 8 equals 8, so that works. All right, so let's try it with this next one to figure out a missing dimension. So to make polyhedron-shaped game pieces using a 3D printer, Juanita enters the number of faces, edges, and vertices into a program. If she wants a game piece with 20 faces and 30 edges, how many vertices does the piece have? So we're going to plug it into Euler's formula. Faces plus vertices equals edges plus 2. Right? It says there are 20 faces. We want to figure out the number of vertices, so I'm going to put V, and then there are 30 edges. So I can solve this. I'm going to simplify, so I get 20 plus V equals 32. I'd subtract 20 from both sides, and I'd get V equals 12. So there are 12 vertices, right? All right, then the other thing we're looking at is cross-section. A cross-section is a thin slice from a solid. So I like to think about going to the deli counter at the grocery store and asking for some sliced deli meat. If I do that, they put it in a slicer and they put this solid in there and they come out with these really thin slices of meat, right? So that's the same thing with a cross section. If you take this solid and you slice it somewhere in the middle, you get this very thin cross section of this solid, right? So let's try to figure out these different shapes. So first, here, looking at this one, let's look at shape M. Well, if M cuts in here, for M, we have this black outline right here, right, which is a diamond. So M, the cross section at M is a diamond. For N, now this figure's rotated, the cross section is right here, right? So N makes a square cross section. All right, so let's try it with these couple ones. What is the shape of each cross section below? So looking at this first one, we have a pentagonal pyramid and it cuts it through here, right? This turquoise slicer goes right through that pyramid. So what is that shape that's formed right there? It would be a pentagon from that cross section, right? It's outlined right here. Okay. A plane parallel to the base for the second one. What would be the cross section of plane parallel to the base? Well, parallel to the base would look kind of like this, right? So it'd be a triangle. Then last one, we're getting a cross section here, a plane perpendicular to the base. So perpendicular to the base would look something like this, right? And that shape I just drew in there is a rectangle. Great. Well, please email me with questions if you have any. I hope you guys are well. Talk to you soon.